Lesson 26, Probability Distribution. Example 7. Construct the probability distribution for betting $1 on a single number, which pays 35 to 1 in the game of roulette, and calculate the corresponding mean and standard deviation. Well, first we're going to construct the probability distribution for this random process. Probability distributions provide the probability for every single possible outcome of the random variable. The result can be displayed either as a table, a graph, or a formula. In this example, we'll provide a probability distribution table. The table consists of two columns. The first column lists all the possible values of the random variable x, and the second column lists the corresponding probabilities of those random variables, or p of x. Now, when we're making a bet in the game of roulette, there's only two possible outcomes. We're either going to win the bet, or we're going to lose the bet. So the random variable x can take on certain values if we win the bet or if we lose the bet. So to determine that, we'll focus on the bet. Here, we're betting $1 on a single number, which pays 35 to 1. When a bet is made that pays odds of 35 to 1, that means for every $1 you bet to risk to lose, you can gain $35 for a win. Thus, in this case, betting $1 on the single number, we're either going to win $35 or we're going to just lose $1. That's what a 35 to 1 bet pays. So in this case, if we win the bet on the single number, we will win $35. This could be represented as a positive 35. Or if we lose the bet, we lose $1, and this is represented as a negative 1. So here's all the possible values of the random variable x. Now we need to calculate the corresponding probabilities, p sub x. So to win a bet on a single number, we only win if the marble lands in that single number slot. And there's only one slot associated with that one single number. So the probability of winning this $1 bet on a single number is just one chance out of the 38 total slots on the American roulette wheel. Now the probability that we lose the bet is the remaining 37 out of 38 slots. Because if the marble randomly lands in any of the other slots that we didn't bet on, we would lose. So 37 out of 38 ways of losing and only 1 out of 38 ways of winning. So here we have the corresponding probability distribution for betting $1 on a single number in the game of roulette. Now we need to calculate the corresponding mean and standard deviation. We will use the Ti84 Calculator to help us do this. To enter the probability distribution into the calculator, we press Stat, Enter to get to the list editor. And then we enter under List 1 the values of the random variable, starting with the positive 35, Enter, and a negative 1, Enter. Then, under List 2, we enter in the corresponding probabilities, starting with 1, divide by 38, Enter, and 37 divided by 38, Enter. Now to calculate the mean and the standard deviation, we press Stat, right arrow to the Calculate menu, Enter to select one of our stats, and then second 1 for list 1, comma, second 2 for list 2, Enter. Now we could read the results for the mean and the standard deviation off the calculator screen. Even though the calculator displays the result for the mean as x bar, we know that when we calculate means based off of the entire probability distribution, we represent that mean with mu sub x for the population mean. So mu sub x for this problem is a negative 0.053 rounded off. And the population standard deviation, sigma sub x, rounds off to 5.763. Again, the units of the mean and the standard deviation are in the same units as the random variable. So the values for the mean and standard deviation here are in dollars, just like the random variable x is in dollars. So here we have our solution. We constructed the probability distribution for betting $1 on a single number in the game of roulette, and the corresponding mean and standard deviation.